There are three possible ways to think about the query flow. You can think about it in terms of the syntax, the select columns from tables. You can think about it in terms of the logical flow, which is the diagram right now. Or you can think about it in terms of the physical flow. And I would suggest you think about it in terms of the logical flow when you're creating a query, because that's the way that it logically makes sense. You select data from a data source. You then filter out or restrict the columns with the where clause. Certain columns are selected, and expressions help also to create the final columns. They can then be sorted in a particular order, and the predicates can finally restrict the rows. It's important to remember that SQL is a declarative language, meaning that you are describing the question or the problem to SQL Server and allowing it to decide how to solve the problem. So you want to avoid thinking about how it's going to actually physically solve this query. So let's jump right into the code. In the project files, there is a script for this lesson. We're in part 2, lesson 1. Go ahead and connect. First, I'm going to increase the size of the font to make it easier to see. A basic select statement only actually requires select and a single expression. For example, here, I'm going to just say select SQL Rocks, F5 to execute, and there's the result. To close the result, Control R is the quickest way to do that. I'm going to switch over to the CHA2 database, so we have the database as the current database. This could also be done with a drop-down box, but the use is the best way to do that in a script, so that if you just execute the script, you're always in the right database. So here's a simple select statement. Just select star from tour. The star means all columns. Not actually a very good practice to do select all columns, because that way you get back extra columns that maybe you don't need. And if the columns change, it's going to select every column and possibly cause problems for the front-end application. But until we talk about columns, I'm just going to say select star in all of our sample code here. So the tour table is a nice, simple table. Not much data in there, but it's going to be good for playing with some of these simple beginner queries. And right at the beginning, I want to point out that the semicolon you're seeing at the end of every one of these select statements is actually a statement terminator. Back in SQL 2000, this was optional, but nobody ever did it. Now in SQL 2005, it is encouraged, and there's a few places where you must use it. We won't see that in this lesson, but we'll see it in a future lesson. And then there's the batch terminator, which is Go. And Go is actually processed by Management Studio so that it can break up large batches into smaller batches. So every time it sees a Go, it stops right there and submits those statements as a single batch. I'm going to reduce the size just to give us a little more room here. So walking through the logical flow of the select statement, the first clause is the from clause. And as you saw on the diagram before, we can actually get data from several different sources, such as tables, subqueries as derived tables, and they can be named, and we'll see that in a couple of lessons, along with common table expressions, views, which are saved queries, and we can see that in a future lesson as well. A user-defined function can actually return data that looks like a table, and we can use that as a source of data. There are a number of functions that can return data from other servers, either other SQL servers or other data sources such as Excel, Access, or Oracle. OpenQuery is the most common one, so that's another source that we could use for our data. And new to SQL Server 2005 is xQuery, which could be used as a data source. So the from clause is extremely powerful in the fact that we can pull data from multiple sources and join them together and create what looks like a new data set, which is then filtered by the where clause and has expressions pulled out from it. In the next two lessons, we'll be talking about the join capability within the from clause, where we can pull together data from multiple data sources and produce what virtually looks like a new data set within this query which is then worked through this logical progression of the query. So the join is discussed in the next lesson. Control R to remove the result pane. One more thing about working with tables and data sources is this idea of a fully qualified or a four-part name. So you notice up above, I just had select star from tour. This is actually a two-part name here, and the four-part name is server.database.schema.object, typically the table name. Usually the server will simply be the local server, so unless you're referencing another server someplace else, the server is left out. The database is typically the current database, defined by the use database. So it's a best practice to identify your tables as schema.object. For example here, schema.object, dbo.tour. And without getting into the nitty-gritty, providing the schema name actually improves performance because SQL Server doesn't have to guess who owns that or which schema you're in. And there are some reusable capabilities that SQL Server can take advantage of if you identify the schema.